Okay, good morning all of you. In last lecture, our unit number 3 is concluded. So today we will start unit number 4. So please write down unit number 4 is theories of elastic failures. Okay, this is totally theoretical unit. In that unit, we will see how material fails or which theories are applied for elastic failures. Okay, so please write down unit number 4, theories of elastic failures. Theories of elastic failure. Okay, first we will see syllabus and then we will discuss one by one. So please write down syllabus. Maximum principal stress theory. Maximum principal stress theory. Maximum principal strain theory. Maximum principal strain theory. Maximum principal strain theory. Maximum shear stress theory. Maximum shear stress theory. Maximum shear stress theory. Total strain energy. Total strain energy. Total strain energy. And distortion energy theory. And distortion energy. And distortion energy. Okay, so under this unit number 4, we have to discuss total 5 number of theories of elastic failures. Okay, so now we will discuss one by one. Okay, please wait. I will share your screen. Okay, so first we will see introduction and then we will see one by one theory. Okay, so simultaneously you can also write. First we will write introduction and then I will explain. So when some external load is applied on a body, okay, please write down, then I will explain. When some external load is applied on a body, some external load is applied on a body, the stresses and strains, are produced in the body. The stresses and strains are produced in the body. The stresses and strains are produced in the body. Full stop. The stresses are directly proportional to the strains, within the elastic limit, within the elastic limit. Full stop. This means when the load is removed, the body will return to its original shape. return to its original shape. Return to its original shape. Full stop. There is no permanent deformation. There is no permanent deformation in the body. There is no permanent deformation in the body. No permanent deformation in the body. Okay. Now I will explain this particular first uh, paragraph. Okay. So suppose we have taken this is block. Okay. This is block and I have applied load on this block. Whenever we will apply load, at that time stress and strain will be developed here. Okay, due to this application of load, stress will be generated because of stress which is equal to load upon area. Okay, applied force upon area, and strain which is equal to change in dimension upon original dimension. Whenever we will apply load, at that time the dimensions of body may be reduced or increased. So whenever we will apply load, due to this application of loading, stresses and strains will be generated in the body. Okay, and this is stress and strains. Okay, these stresses are directly proportional to the strains. Okay, so within elastic limit, stress is directly proportional to strain within elastic limits. That means it obeys Hooke's law. Okay, Hooke's law states that stress is directly proportional to strain within elastic limit. So whenever our material is in elastic limit, at that time, suppose we have taken this body and I have applied load. After removal of this load, body regain its original shape and size. This is called as elasticity, and under such condition body does not go under permanent deformation. Okay, so this is the first paragraph. Then we will move towards next para. Write down please. However, if the stress produced in the body, if the stress produced in the body due to the application of load, Swalpaviram is beyond the elastic limit, is beyond the elastic limit, Swalpaviram, the permanent deformations occur in the body. Permanent deformations occur in the body. Permanent deformations occur in the body. Full stop. This means if the load is removed, the body will not retains its original shape. The body will not retain its original shape. Body will not retain its original shape. Full stop. There are some permanent deformation in the body. There are some permanent deformations in the body. Some permanent deformations in the body. Full stop. Whenever permanent deformations occur in the body, whenever permanent deformations occur in the body is said to have failed. The body is said to have failed. The body is said to have failed. Full stop. This should be clear that 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 failure does not mean rupture of the body. Failure does not mean failure does not mean failure does not mean failure does not mean a rupture of the body. Okay, so now I will explain this para. So already we have discussed, whenever we will apply load on a particular body, some stresses and strains will be generated. Okay, but if this stress and strains within elastic limit, at that time permanent deformation is not occurred. If this stress and strains, that is generated stress and strain, will be beyond elastic limit, that means it crosses the elastic limit, at that time permanent deformation is occurred in the body. म्हणजे काय होते बघा, जर इलास्टिक लिमिटच्या बाहेर जर तुमच्या मटेरियलचे स्ट्रेसेस अँड स्ट्रेन जनरेट होत असतील, तर ऍट दॅट टाइम परमनंट डिफॉर्मेशन विल ऑकर. ओके, सो परमनंट डिफॉर्मेशन मीन्स व्हाट? Okay, suppose we have taken this body and applied load. After removal of this load, body does not regains their original shape and size. This is called as permanent deformation. Okay, permanent deformation. And this permanent deformation is occurred when, if thus generated stresses and strains beyond the elastic limit, at that time permanent deformation is occurred. Whenever this permanent deformation is occurred, at that time body may fail or rupture. Okay, so this is the second part. Then we will move towards next paragraph. Please write. Let us consider, let us consider, let us consider, let us consider, let us consider the failure in bracket or permanent deformation, permanent deformation of a bar, permanent deformation of a bar in a simple tensile test, in a simple tensile test, full stop. The tensile stress is directly proportional to the tensile strain up to elastic limit. The tensile stress is directly proportional to the tensile strain. Tensile stress is directly proportional to the tensile strain up to elastic limit. Up to elastic limit. Full stop. Up to elastic limit. Full stop. This means that there is a definite value of tensile stress up to elastic limit. Tensile stress up to elastic limit. Full stop. Beyond the elastic limit, if the tensile stress increases, the failure of the bar will take place. The failure of the bar will take place. 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 Full stop. At this stage, at this stage, at this stage, why the failure takes place? Why the failure takes place? At this stage, why the failure takes place? Okay, question mark. Now we will see why the failure occur. Okay, it may be due to, it may be due to, it may be due to the increase of tensile stress, the increase of tensile stress, the increase of tensile stress, or due to, or due to other quantities, or due to other quantities, due to other quantities, due to other quantities such as shear stress and strain energy, shear stress and shear stress and strain energy, shear stress and strain energy also attain definite values, also attain definite values, also attain definite values, and any one of these may be deciding, any one of these may be deciding, may be deciding, may be deciding factor of the failure of the bar, factor of the failure of the bar. Factor of the failure of the bar. Okay. Full stop. Certain theories have advanced to explain, certain theories have advanced to explain, advanced to explain the cause of failure, the cause of failure, the cause of failure. Full stop. According to the important theories, according to the important theories, according to the important theories, the failure takes place, failure takes place, failure takes place when a certain limiting value is, when a certain limiting value is reached by one of the following, 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 reached by one of the following. Okay, so here 5 theories are noted, so you also write down. First one is the maximum principal stress theory. First one theory is maximum principal stress theory. Second one is the maximum principal strain theory, maximum principal strain theory. Third one is the maximum shear stress theory, maximum shear stress theory. Fourth one, maximum strain energy theory, maximum strain energy theory. And last one, that is the maximum shear strain energy theory, maximum shear strain energy theory, maximum shear strain energy theory. Okay, so now we will see this last paragraph. Okay, so now we will consider the bar is in permanent deformation. Permanent deformation means whenever we will remove the load, at that time particular member does not regains their original shape and size. Okay. So this permanent deformation of bar in a simple tensile test. Okay. In a simple tensile test. We will consider in simple tensile test. Okay. So already you know that. Suppose the particular bar is obeys Hooke's law. At that time, tensile stress is directly proportional to tensile strain. Okay, suppose our bar is obeys Hooke's law. At that time, tensile stress is directly proportional to strain. Okay, Hooke's law states that within elastic limit, stress is directly proportional to strain. But this stress is directly proportional to strain is valid up to elastic limit. Okay, up to elastic limit. Okay. Suppose beyond this elastic limit, the stress is increases. Beyond this elastic limit, that means our elastic limit region is over and our tensile stress is increased. At that time, this bar may failure. Okay, this bar may be failure. Okay, and why this failure takes place? Now we have to see why this failure takes place. Okay, so this failure may be increase of tensile stress. ओके सो हे फेल्युअर कशामुळे ऑकर होणार आहे तर टेन्साइल स्ट्रेस इनक्रीज झाल्यामुळे और अदर ड्यू टू other different parameters such as shear stress, strain energy. Okay, due to this bar may failure and certain advanced theories are developed for finding out this failure. So in that there are total 5 theories. First one is maximum principal stress theory. Second one is maximum principal strain theory, maximum shear stress theory, maximum strain energy, and maximum shear strain energy. So if if our bar is beyond the elastic limit, that means this particular bar does not obey Hooke's law. At that time, tensile stresses will be increased, and due to these increased stresses, the failure of bar will occur, and this failure we will find out by using these 5 theories. Now we will see 5 theories one by one. Okay, so please write down first theory. Write down first theory. First theory, maximum principal stress theory. Maximum principal stress theory. Maximum principal stress theory. Maximum principal stress theory. First we will write and then I will explain. Okay. So first you write down who has developed this stress theory. Okay. So this chapter is totally theoretical chapter and number of MCQ may be asked on this unit. So MCQ likewise, maximum principal stress theory was developed by and scientist name was given. Okay, so at that time you have to remember maximum principal stress theory was developed by Rankine. Developed by Rankine. I will write here. You can also write. So you have to easily remember. Write down first sentence. This theory was developed by this theory was developed by Rankine. This theory was developed by Rankine. Okay, just you have to remember maximum principal stress theory is developed by Rankine. Okay, and after that you continue. According to this theory, the failure of a material will occur. Failure of a material will occur. Failure of a material will occur. Failure of a material will occur when the maximum principal tensile stress, when the maximum principal tensile stress sigma 1 in the complex system reaches the value of reaches the value of reaches the value of reaches the value of maximum stress at the elastic limit. Maximum stress at the elastic limit in simple tension in simple tension or now this is for minimum principal stresses, or the minimum principal stress in bracket that is the maximum principal maximum principal compressive stress maximum principal compressive stress reaches the value of reaches the value of maximum stress at the elastic limit in simple compression at the elastic limit in simple compression in
मॅम
yes
प्रिव्हियस स्लाइड दाखवा ना.
okay wait yes
ओहर मॅम.
okay now we will write. Okay, so simply if you have not possible to remember particular sentences, at that time you write down. Okay, simply in simple word you write down. I will also write here maximum principal stress should be less than yield stress less than yield stress. So simply you remember this sentence, maximum principal stress. Already you know that principal stresses are denoted by sigma 1 and sigma 2. Sigma 1 is maximum principal stress and sigma 2 is minimum principal stress. So sigma 1, that is maximum principal stress, should be less than yield stress. This is the theory of maximum principal stress. And by mathematically you write down, so you have to easily remember. By mathematically sigma 1 means maximum principal stress should be less than or equal to sigma y divided by factor of safety. Sigma y divided by factor of safety. So sigma y means yield stress. Sigma y means yield stress. Sigma y means yield stress. Okay, so this maximum principal stress theory states that maximum principal stress should be less than or equal to yield stress. Okay, so yield stress means sigma y. And here this factor of safety is taken. Factor of safety. Suppose factor of safety is 1. At that time, sigma 1 should be less than or equal to sigma y. Okay. So this is for maximum principle. And simultaneously we will write for minimum principle. Mod sigma 2 which is less than or equal to sigma y by factor of safety. Same. So minimum principal stress should be less than or equal to yield stress divided by factor of safety. I have taken here mod. Why this mod is taken here? Anyone? Why this mod is taken here? Okay, whenever we have solved examples, at that time we got minimum principal stress is in compression. That means we got sigma 2 value is in negative. So for this negative, we have taken here mod. So according to this maximum principal stress theory, maximum principal stress should be less than or equal to yield stress, and minimum principal stress should be less than or equal to yield stress. This is the theory related to maximum principal stress theory. Okay, maximum principal stress theory. For that, how to draw envelope? I will draw envelope. Simultaneously, you can also draw. Then we will move towards next theory. Okay, so please wait. I will draw. Okay, my screen is visible.
Yes, ma'am.
Okay, so now we will draw here. Okay, already you know that sigma 1, that is maximum principal stress, will be plotted on x-axis. Here sigma 1, and on y-axis sigma 2, that is minimum principal stress. Okay, and here we have to draw sigma star. We have to draw sigma star. So this is sigma star. This is also sigma star. Here also sigma star, but this is in negative, and here also sigma star, this is in also negative. Okay, so this is the envelope. Suppose this is A, B, C and D, A, B, C, D portion. Okay, so here suppose this is sigma and this is also sigma. Okay, suppose our stress is plotted here. Suppose our stress is plotted here or here or here. That means our material or member is safe. And if our stress or member is beyond this envelope, at that time this indicates the failure is occurred. So this is the envelope. Likewise, we have to draw failure envelope for maximum principal stress theory. Maximum principal stress theory. Maximum principal stress theory. Okay. Simply you have to remember that sigma 1 should be less than or equal to sigma y by factor of safety, and mod of sigma 2 should be less than or equal to sigma y upon factor of safety. That means in word you have to remember that maximum principal stress should be less than or equal to yield stress. Should be less than or equal to yield stress. Okay. Over. Over.
Yes, ma'am. Yes, ma'am.
Okay. So we will see second theory. Please write down next theory. Write down second theory. Maximum principal strain theory. maximum principal strain theory. You just write down that much. Maximum principal strain theory. Maximum principal strain theory. Maximum principal strain theory. Okay, so here also chances to ask in MCQ. So MCQ on this theory was developed by and scientist name was given. So first write this theory is due to Saint Venant. This theory is due to Saint Venant. That means this theory is developed by Saint Venant scientist. Okay, this theory is due to Saint Venant. Full stop. According to this theory, 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 the failure will occur, the failure will occur, failure will occur, failure will occur in a material, in a material, in a material, in a material, when the maximum principal strain, when the maximum principal strain, when the maximum principal strain, maximum principal strain reaches the strain due to yield stress, reaches the strain due to yield stress, strain due to yield stress in simple tension, in simple tension, in simple tension, or when the minimum principal strain, when the minimum principal strain, minimum principal strain, when the minimum principal strain, that is maximum compressive strain, that is maximum compressive strain reaches 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 the strain due to yield stress in simple compression, the strain due to yield stress in simple compression, simple compression. You write down that much. Okay, so first we will write mathematically, so you have to easily understood. So by mathematically, please write down, then I will explain. Mathematically, epsilon 1 should be less than or equal to sigma y divided by E into factor of safety. Epsilon 1, that means major principal strain, major principal strain, major principal strain. So major principal strain is denoted by using epsilon 1. Okay, because of strain is denoted by epsilon and major, so epsilon 1, and minor principal strain will be denoted by epsilon 2. So according to this theory, okay, according to this theory, so this theory was developed by Saint Venant scientist. Saint Venant scientist. Please remember this. One MCQ will be asked definitely. So according to this theory, when failure is occurred, if the maximum principal strain reaches to yield strain, at that time failure will be occurred. So by mathematically, epsilon 1, that is major principal strain, should be less than or equal to yield stress divided by E into factor of safety. This is related to epsilon 1. Now we will see by taking the effect of Poisson's ratio. So epsilon 1, which is equal to sigma 1 upon E minus mu into sigma 2 upon E. Mu into sigma 2 upon E. So this is the formula for considering Poisson's ratio. for considering Poisson's ratio. So you just remember this and this also. Okay. So this theory states that failure will occur when major principal strain or maximum principal strain reaches the yield stress in simple tension. So failure will occur. That means epsilon 1, that is major principal strain, should be less than or equal to yield stress divided by E into factor of safety. And whenever we will consider Poisson's effect, at that time epsilon 1, which is equal to sigma 1 upon E minus mu into sigma 2 upon E. Now we will draw failure envelope for this particular theory. Okay. So simultaneously you can also draw. Okay. So this is center point O, O to A and O to B. So these are the sigma, that is plus, and O to B and O to C are the minus. That means here major principal stress and here minor principal stress will be occurred. So this is the failure of maximum principal strain theory. Maximum principal strain theory. Maximum principal strain theory. Maximum principal strain theory. Strain theory. Maximum principal strain theory. Maximum principal strain theory. Please draw fast.
Good, ma'am.
Okay. Next, we will see next theory. Please wait. I will share screen. So please write down next theory. Third theory. Okay. Write down next third theory, maximum shear stress theory. Maximum shear stress theory. Maximum shear stress theory. Maximum shear stress theory. So first, this theory is due to Gust and Tresca. This theory is due to Gust and Tresca. This theory is due to Gust and Tresca, therefore known as gust theory. Therefore known as gust theory. So this theory is developed by Gust and Tresca scientists, and according to this theory is called as gust theory. So you remember, maximum shear stress theory is developed by Gust and Tresca. So this theory is called as gust theory. Okay. Now according to this theory, according to this theory, according to this theory, according to this theory, the failure of a material will occur. The failure of a material will occur. Failure of a material. Failure of a material will occur. Failure of a material will occur. Failure of a material will occur. Failure of a material will occur when 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 the maximum shear stress in a material, 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 maximum shear stress in a material reaches the value of 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 maximum shear stress, maximum shear stress, maximum shear stress in simple tension, in simple tension at the elastic limit, simple tension at the elastic limit. Full stop. The maximum shear stress in the material, maximum shear stress in the material, maximum shear stress in the material is equal to half the difference between maximum and minimum principal stress, maximum and minimum principal stress. Okay, so now we will see this theory is This theory was developed by Gust and Tresca. So this is called as Gust theory. Okay. So whenever if the maximum shear stress in the material, maximum shear stress. So tau max, how to find out maximum shear stress? Tau max, which is equal to maximum principal stress minus minimum principal stress divided by 2. So the maximum shear stress in the material is reaches to yield stress, is reaches to yield stress. So by mathematically, by mathematically, sigma 1 minus sigma 2 divided by 2 should be less than or equal to sigma y divided by 2 into factor of safety. 2 into factor of safety. That means maximum shear stress reaches to the yield stress. Okay. So how to find out maximum shear stress? Already you know that. Tau max, which is equal to tau max, which is equal to tau max, which is equal to tau max, which is equal to. So maximum shear stress sigma 1 minus sigma 2 divided by 2 should be less than or equal to. So yield stress. So in yield stress, maximum stress is sigma y and minimum stress is 0 divided by 2 into factor of safety. So according to this equation, this formula will comes. Okay. So maximum stress should be reaches, maximum shear stress should be reaches to yield stress, and at that time failure will occur. So this is the formula. Now we will draw envelope for this particular theory. Envelope for this particular theory. Suppose this is y-axis, this is x-axis. Okay, this is x-axis. So suppose this is A point, this is B, C, D, F. So here on y-axis sigma 2, on x-axis sigma 1 is there. So here sigma star, that is plus, here also sigma star, that is plus, and here also minus sigma star, and here minus sigma star. So this is the envelope for this maximum shear stress theory. If our stress is beyond this limit, so our material will fail. And if our stress is within this envelope, so our material will be safe. So these are the theories related to elastic failure. So remaining two theories we will see in next lecture. Please draw fast.
Recording in progress.
Over, ma'am.
Please wait. I will take screenshots for attendance. And then you can leave the meeting. Okay. So today we have discussed three theories. Okay, and remaining two theories we will continue in next lecture. Thank you for attending lecture. We will stop here.